A right triangle is a triangle in which one of its angles is a 90-degree angle. This 90-degree angle is represented by a square. The side across from the 90-degree angle is called the hypotenuse. The other two sides are called the legs. The legs are assigned the variables a and b, and the hypotenuse is assigned the variable c. The Pythagorean theorem is named after the Greek mathematician and philosopher Pythagoras, who lived circa 570 BC to 495 BC. When you have a right triangle and the length of two of its sides are known, you can find the length of the third side by using the Pythagorean theorem. The Pythagorean theorem states that in any right triangle, the sum of the squares of the legs equals the square of the hypotenuse. In other words, a squared plus b squared equals c squared, where a and b are the variables representing the legs, and c is the variable that represents the hypotenuse. Let's take a look at how we use the Pythagorean theorem. Example 1. We have a right triangle. The length of the hypotenuse is unknown, so it is assigned the variable x. One of the legs has a length of 3 units, and the other has a length of 4 units. We have to solve for the value of x. In our Pythagorean theorem, we're going to substitute the variables a and b with the values of the legs, 3 and 4. It doesn't make a difference which leg you substitute for a and which leg you substitute for b. We're going to substitute the variable c with the value of the hypotenuse. Since we don't know the value of the hypotenuse and it's represented by the variable x, we can substitute the variable c with the variable x. You can also choose to use the variable c if you prefer. It makes no difference. Now, in order to solve our equation, we must simplify the left side of the equation, always making sure to follow the order of operations. So first, we'll do the exponents. 3 to the second power is 9, and 4 to the second power is 16. Now we add 9 plus 16, and that gives us 25. So x to the second power is equal to 25. But we're trying to solve for x, not for x to the second power. So we still need to undo the exponent above the x. In order to undo it, we need to do the opposite of squaring a number. The opposite of squaring a number is finding the square root of that number. That means finding what number times the same number will equal the number which is underneath the radical sign. Since x times x equals x to the second power, we know that the square root of x to the second power is x. And since 5 times 5 equals 25, we know that the square root of 25 is 5. This brings us to our answer, which is x equals 5. Our second example is just like our first example. We have a right triangle. The hypotenuse is unknown, so it is represented by the variable x. The legs of the right triangle have lengths of 15 and 8. We're going to go to our Pythagorean theorem equation and substitute the values of the legs for a and b, and we'll substitute the variable c with the variable x. 15 to the second power is 225, and 8 to the second power is 64. We add 225 plus 64, and that gives us 289. Now we get the square root of 289, and that gives us our answer, x equals 17. For our third example, we have a right triangle, and this time we do know the value of the hypotenuse. Our hypotenuse is 39. However, we only know the value of one of the legs, which is 36. The other leg is unknown, and we have to solve for the value of that unknown leg. In our Pythagorean theorem equation, we're going to substitute the variables a and b with the values of the legs, x and 36. We'll substitute the variable c with the value of the hypotenuse, 39. Following the order of operations, we first simplify our equations by doing the exponents first. 36 to the second power is 1,296. 39 to the second power is 1,521. Now, in order to solve for x, we need to isolate the variable x on one side of the equation. In order to do that, let's get rid of the 1296 on the left side of the equation by subtracting both sides of the equation by 1296. This gives us the equation x to the second power equals 225. Now once again, since we're trying to solve for x, we need to undo that exponent above the x by getting the square root of both sides of the equation. This gives us our final answer, x equals 15. Example 4 is similar to our first two examples with a slight twist at the end. The hypotenuse is unknown and the legs have values of 2 and 3. We substitute a and b with the values of the legs, 2 and 3, and we substitute c with the value of our hypotenuse, x. 2 squared is 4 and 3 squared is 9. We add 4 plus 9 and that gives us 13. We then get the square root of both sides of the equation, but 13 does not have a perfect square root, so we are left with two options. We can either leave our answer in radical form, always making sure to simplify your radical if possible, which would give us an answer of x equals the square root of 13, or we can use a calculator to write our answer in decimal form by finding the square root of 13, which is approximately 3.61 if you round your answer to the nearest hundredth. In our last example, we are given the length of the hypotenuse of our right triangle, 10, but we have to solve for the length of one of the missing legs. We start by substituting the variables a and b in our Pythagorean theorem with 7 and x, and we'll substitute the variable c with the value of our hypotenuse, 10. Let's simplify the exponents first. 7 to the second power is 49 and 10 to the second power is 100. We want to isolate the x variable on one side of the equation, so let's get rid of the 49 by subtracting 49 from both sides of our equation. That gives us x to the second power equals 51. We get the square root of both sides of the equation, but once again we have a number, 51, which does not have a perfect square root. The square root of 51 cannot be simplified any further, so we can either leave our answer written in radical form, x equals the square root of 51, or we can use a calculator to write our answer in decimal form, x equals approximately 7.14, rounding to the nearest hundredth. Now it's time to practice what you just learned. You have 3 problems. You'll need a piece of paper, a pencil or a pen, and a calculator is optional. Use the Pythagorean theorem to solve for x in each problem. You'll have 30 seconds to solve, and if you need additional time, pause the video. After the 30 seconds are up, we'll look at the answers. Your 30 seconds begins right now. Time's up. Let's check our answers. How well did you do? Make sure to let everyone know how well you did in the comments. If you found this video helpful, take 1 second to hit that like button and subscribe to the Math Discipline channel so that you can always have access to the best math lessons online. Don't forget to share this video with your friends so that they can get awesome at math too. Thanks for watching.